Of the compounds we made last class, some of them have the same formula but different structures. These are called isomers. What we're going to look at in this video is how to name branched alkanes. The first example of a branched alkane that we came across is C4H10. Here are the two forms of C4H10. So this is the straight chain alkane, 4 carbons. This would be called butane. This is the isomer. It still has the same structure, C4H10, but what is its name? So, what are the rules for naming more complex alkanes? The root of the name, or the parent name of the compound, is from the longest chain, the longest number of carbon-to-carbon bonds we can have without going back on ourselves. So here we can clearly see that we can have 1, 2, 3 carbons. 1, 2, 3. 1, 2, 3. 1, 2, 3. Before we come to the end of the chain. So the longest chain is 3. Rule 2. Number the carbon atoms so the side chain has the lowest number. The side chain is anything that's coming off the main chain. We can also call it a substituent group. A substitute is when we replace something with something else. So here a hydrogen has been taken off the chain and replaced with another group. In this compound we can see that basically it doesn't really matter where we start numbering this compound. Let me just find my thing. 1, 2, 3, or 1, 2, 3, or 1, 2, 3, or so on. 1, 2, 3, 1, 2, 3. It doesn't matter. Carbon 2, this middle carbon here, is always going to be the one that has the other group coming from it. The other group, we'll use this one, is CH3. CH3 has 1 carbon, so that means it is meth, and we basically call it methyl. Okay, we put YL on the end to signify that it is a substituent group versus the main chain. Okay, another thing to point out with this, so this will be 2-methyl propane, is first of all this 2 here is actually not really needed because, as we saw in the previous slide, it can only be carbon 2. But we indicate the number, and this is the group. So on carbon 2 there is a methyl group, and that methyl group is attached to propane. Notice how we separate numbers and words with a dash. So this is the basic rule we apply for anything. And before we said sometimes you might get molecules confused because they look different. How we know that they're not different, or how we can tell if they are or are not different, is when we start to name them. So these two molecules here that we've seen before look different, but if we actually look, we've got 1 carbon, 2 carbons, 3 carbons, 4 carbons, all attached to each other, and here are 1, 2, 3, 4, all attached to each other in a straight line, so they're both the same molecule, even though they look different. So here are 2 C6 isomers of 6 carbons. Okay, we can practice this one. We have 1, oops, we have 1, 2, 3, 4, 5, 6, we have 1, 2, 3, 4, 5, 6. Okay, are they different? Well, let's have a look. This one here is a straight chain, so it would be called 6 is hex. This will be hexane. The longest chain here is 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Okay, or 1, 2, 3. Well, it's not 3, so it must be 5. So this will be pentane as the parent name, and the shortest number of carbons, 1, 2. And this we can take as the side group, or this one, 1, 2. So this will be 2 methyl pentane. Okay, here are two more. Here we have two isomers of pentane. Okay, now let's have a look again. 1, 2, 3, 4. There's my 5 carbons that make it C5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Okay, so 4 is the longest chain. So if we look at this, so we've got 1, 2, 3, 4. Okay, they both look very different. But when we name them, we're going to find that 1, 2, 3, 4. Okay, so the smallest number is 2 before we reach the branch. So this will be 2-methyl butane. And this would be 1, 2, 3, 4, 1, 2, 3, 4. Okay, so this is going to be 2 again. So this is also 2-methyl butane. So even though the molecules look different, they're exactly the same. And in fact, this one and this one have just been turned over. So this is the straight chain. So this has 1, 2, 3, 4, 5. This is. So now we're going to quickly look at the different isomers of C5, H12. Okay, this is the straight chain isomer, so this is going to be just called pentane. This isomer still has 5 carbons, has a side chain. Longest chain is 4. So that means that the root of the name is going to be bute. So this is butane. Substituent group is coming off carbon 2. And the substituent group is methyl, 1 carbon, methyl. So this is 2-methyl butane. And this one is, it's not 3-methyl. Okay, it's 2-methyl. You just got to start numbering. Remember the smallest number. 1, 2, 3, 4. Have to start numbering from this side. Okay, 1, 2, 3, 4. This is also 2-methyl butane. There is one other isomer with 5 carbons, and this is it. Longest chain, 3, which makes it propane. Okay, this one's a bit more complex because here we go, 1, 2, 3. This one has 2 substituent groups. We haven't got a rule for 2 substituent groups, so here comes the next rule. The next rule. So if you have more than one side group, we have to show this by using a prefix in front of the group. Or, in nicer words, if the same substituent occurs more than once, the number of each carbon of the parent chain on which the substituent occurs is given. In addition, the number of times a substituent group occurs is indicated by a prefix: di, tri, tetra, penta, hexa, and so on. And there it is in writing for you. So the prefix di means 2. Dimethyl means 2 methyl groups. Tri means 3. Triethyl means that there are 3 ethyl groups attached to the main chain. 4 groups is tetra. Remember, the groups have to be the same, not 4 different groups. So, here's our compound. What's it called? So, we have as our substituent groups a methyl group. In fact, there are 2 of them, so that makes it dimethyl. And the parent atom, the longest group, is 3, which makes it propane. So this is dimethyl propane. Technically, we should put, because it's off carbon number 2, we should put 2,2-dimethyl propane. The comma is used to separate the numbers, and the dash to separate numbers from letters. To be honest, for this molecule, this isn't really needed because it has no choice but to go on carbon 2. Otherwise it would be another compound. Rule 3. Oh, can you read that writing? Ooh, scary writing. Okay, so again, show the locations of the substituent groups before the name. So here's another one for you to try. I'll talk you through it if you wish. What is the longest chain? Okay, on the longest chain, what groups are there coming off? What branches are there? Are they the same? Number the carbons to give the lowest possible numbers for those side chains. 2, 3, dimethyl pentane. Now, if you want to go above C6, be my guest, but to be honest, you've got all the rules now. You need to name everything up to and including all the isotopes of C6H14. So, here are the different isomers of C6. There's one. You can pause and try to name it. Here's another. Again, pause. Try to name it. Here's another. Okay, I'll just point out that there's a carbon underneath this hydrogen that's sticking out and blocking it. So again, it's another C6 compound. And here's another. And here are the answers. So here's the compact, what did I call it before? I forgot what I call it now. Here's the structural formula. Okay, the compact structural formula. This is a straight chain alkane, it's a hexane. Here we have a methyl group coming off, and then we're putting it in the middle carbon. So this is going to be 3-methyl pentane. Okay, we can also move that methyl group over a carbon. So that would be 2-methyl pentane. Again, don't get confused. 2-methyl pentane and 4-methyl pentane are the same compound. 4-methyl pentane will not exist just because of the naming system that we use. Okay, this time we're going to take 2 methyl groups. So this would be longest chain, number of substituent groups, location of substituent groups. So this would be 2, 2, dimethyl butane. And here's the other possible molecule. Again, longest chain is 4. There are 2 substituent groups, both are methyl groups. So this will be 2, 3 dimethyl butane. Okay, obviously there are more complex ones. If we go above C6, we start getting into some kind of really funky molecules. There are many more rules than I'm giving you here, but we're just going to try to keep it kind of fairly simple for you. So in this case, well, just follow the rules we have so far. So the longest chain is, well, let's see, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So the longest chain is 6. So this is going to make this molecule end hexane. Okay, that's the parent molecule. And the 6 carbons we've just drawn are these. So this will be 1, 2, 3, 4, 5, 6. Yes, we could number the other way. We could number this 1, 2, 3, 4, 5, 6. But 2 is a lot smaller than 3. So we have to number it so we get the smallest possible number. So 2 is the smallest possible number. So this will be 2 and a 4. Okay, let's have a look at the different groups we have. We have a methyl and a methyl. and we have this, which is 2 carbons, so it's ethyl. Now what we do now is we do it alphabetically. So alphabetically, ethyl comes before methyl. So this is going to be ethyl first. Now the ethyl is of carbon 4, so this is going to be 4-ethyl. Okay, remember, separate words and numbers by a dash. And then we're going to have, of carbon 2, and of carbon 2 we have 2 methyl groups, so it's going to be 2,2-dimethyl hexane. Apologies for my methyl. Okay, and that's naming compounds. There is a sheet, a worksheet to accompany this to summarize these rules. Okay, and there'll be some practice questions as well if you wish to try them. Good luck, enjoy, it's a lot of fun, I promise.